go over really quickly how to fix some issues that we encountered from users and whatnot. Just to let you know, what happened was when we did the update, we actually changed the format for SI Raven so that it would accommodate optimizations properly and do like it work properly with the strategy analyzer using optimizations. And as a result of that, kind of NinjaTrader would sort of take the older versions of SI Raven, expect it to have the same kind of parameters, and would try to load that in, and it wouldn't work. And so people were starting to see deserialization errors. So I just want to quickly show you where to go if you see a deserialization error, and it's really simple. What it is NinjaTrader just stores a basically, I guess you could say, a configuration of any strategy that you run, and actually even any indicator that you run on the drive somewhere. And really, it's just in the if you go to your My Documents folder under NinjaTrader 7, and you go to templates, under here, under strategy and or indicator, you may see some stuff there. So if you go to strategy, okay, mine is empty right now, but you might see something here like SIRaven.xml or SI strategy BloodHound.xml. You're safe to just delete those. Okay, so all you gotta do is just delete those, and the errors will go away. Okay, so what I'm talking about is when you jump in, and sometimes right after update BloodHound, and you jump into your system, and you're posting a deserialization error. All you have to do is just simply go to that folder that I showed you, and delete the XML file that you see here. Okay, so it's under, again, NinjaTrader 7 templates, indicator or strategy. I might have some in here, I don't know, but okay. Anything under these two are essentially expendable. They're just basically light configuration files that are just trying to remember the last settings you used for SI Raven or whatnot. And since the majority of your settings are actually stored in your template file, deleting these will not affect your template files and your sophisticated BloodHound configurations and whatnot. All they do is just affect simple stuff like what you set your stops at and whatnot, which are very easy to just simply recreate. All right. So with that, I'm also just again announcing that sort of knee deep into working on the divergence indicator, and those of you that have expressed interest in beta testing it, I have you on a list, so I will try to send something to you guys as soon as I can when I have something that isn't quite so broken. But when I've got it sort of further along on the development there, that I can show you something that obviously won't be perfect, but will give us a basis to sort of form a discussion around in terms of if it's heading the right direction or not. And hopefully that will be fairly soon. But I won't make any promises just because things do pop up every once in a while. Also, I will endeavor to start getting these recordings up a little sooner. We just apologize. We just had a little bit of backlog there of past recordings. I'm finally encoding last week's demo right now, or workshop right now. So, as soon as that's done, I'll be encoding today's webinar, which means we'll be essentially caught up by the end of hopefully tomorrow night, I'm thinking. These encodings take sometimes 7 to 8 hours to perform. Anyway, let's move on, and I'll pass the mic over to Zach, who's going to answer a fairly extensive question that came in from one of our existing customers here, and we'll have him step through building aspects of his system. Okay.
Thanks, guys. Thanks, Jeremy. Let me switch the screen over. Alright. Almost done. Alright, you guys should be seeing my monitor now. So hopefully you guys can see the chart I have up. And it's kind of set up right now to answer a request from Adam. So he's got kind of three moving average system here, and he wants to use a MACD histogram filter on it. So this shouldn't take too long, and we'll get through this. And then after that, if there's no more questions, then we'll move on to the function nodes. All right, so the first part of this system is the red line is a 200 period moving average. The dashed line is a 50 period, and the solid white is a 17 period. So you can see them on my chart here, 200, 50, and 17. So when when the medium, or the 50, so we're going to call this like the slow. The red is going to be the slow, the dashed line will be the medium, and the solid line will be the fast. So when the medium is above the slow, it's actually a condition for shorts, to go short. And so what we're looking for is the condition to go short is when the fast moving average crosses down below the medium, and the medium is above the slow. And so that's the primary signal condition there. And then we'll filter, we'll set up a MACD histogram filter as well. Alright, first let's see if there's any new people. Let's see. I think there's a couple of new people in here. So let me remove BloodHound and go through the process of setting it up and kind of start from scratch. So, all right, so we're going to right-click on the indicator, and BloodHound is down in the S's under SI. Let's see, there we go. SI BloodHound. Add it to the chart. And just going to hit OK. Alright, there we go. Now you can see that we have the button up on the top of the chart, and the pull-down menu. This pull-down menu is for the logic templates that you can define later on. So we'll select the button, and that brings up the window. So here's BloodHound's interface. So you'll notice there's some pull-down menus. All right. So you'll see in the file pull-down, we have the most recent 20 BloodHound templates that show up here. If you need to see, older templates, if you have more than 20, you can just use the file open, and it'll show all of your templates. I would suggest, as you kind of build your system and you want to start testing different conditions and whatnot, you can use the save as, so that way you're working with a different template, and that way you keep your original safe, kind of like your root system safe. So you can see we have a clear. So if I add a bunch of solvers on there, and I just want to start from scratch, I can just hit clear. Clears them all. And then the help, if you have some questions, click on the online support, and it opened it up on my web browser, which is open on another window. But here, let me drag it over. So that one takes you to our support center, which is run by Zendesk here. So there is some information here to be some useful information. So, like the error that Jeremy just described this morning, it's written right here, and how to clear it. There's the announcement of our 1.1 public beta. So various announcements, and Jeremy puts them up here. You can go into the support forum, and there's a tips and tricks section here. So you guys are probably familiar with the tips and tricks video section, which is on the Shark Indicators website, but in our Zendesk ticket, these are basically older. We started doing these last year, and they're not videos. Let me pick a common. Here's a common one up on top. They're written screenshots here. And this is how originally I was doing the tips and tricks. So you can click on the image, it'll enlarge it for you. And let me go back. The community help general support is kind of like a FAQ section. Lots of frequently asked questions. If we get a lot of repeat questions, we'll post those in here. And so announcements. That's what a lot of these announcements are in the home page. And if you have any requests that you'd like to see, any improvements or additions to BloodHound, we have this feature request section right here. So you can check this to see if your request has already been asked. But you can submit your request. There's no way to directly submit your request in here. If we get a request, we'll move it into this area. But the way you can send us a request is from our main website. So I'll just get this guy to load up. Alright, so under support, you can just use the contact us. Right, so you can use this support query here, also for the feature request, or just anything, any kind of question you got for us, or suggestions or comments, whatever. Yep, use this, and so this form here, what it does is it sends your request into our Zendesk ticket system. That way, Jeremy and I can both see it. And it just works a lot better. I know some of you guys have our email address, but using this form is much better than emailing us personally. That way we can both see the question. And let's see. So let's go through some other ways to get support for BloodHound. So you see in the BloodHound pull down, we have the Learn BloodHound, and this is a fairly recent page that we just added, the Getting Started page. So from here you can just basically kind of work your way down through the information. The first step would be the tutorial videos. So this button here will take you over to the tutorials. Then next step down is just to continue on. There's more info. And then it takes you into previous workshop videos where a few months back I went through each of the solvers in depth, walked through them. There's those videos, various videos, and then just for extra practice, then we'll take you to the tips and tricks, and then finally on to Raven. Right. You'll also see some other examples that are available for each specific solver is on the documentation page. If we go to documentation, you'll see over here on the right hand side under BloodHound reference, you'll see each of the individual solvers, the logic nodes, Raven, and you can even write your own custom, or you can, so if you have a custom strategy written already that you'd like to use that, that has custom stops and stuff like that that you might have programmed yourself or have a programmer do, you can implement BloodHound into your own custom strategy here. In this section here, I'll show you how to do that. But let me kind of get back to the documentation for each solver, right? So if you're wanting to kind of get some more practice using the support and resistance solver, you can click on that and scroll down. You'll see all the the description of each parameter, and then down towards the bottom. So here's the video tutorial. I'll take you straight to it, and then down here is some examples, written examples. Once again, you can click on the image, it'll enlarge it for you. So and let's see what else. This support center right here takes you to our Zendesk. That's this, our Zendesk support center. Yeah, so that's kind of a quick summary of various ways to get help. So let me kind of minimize this guy. All right, and we'll keep on going with the BloodHound interface. So you can see, I just put BloodHound on the chart, and essentially the first thing you really want to do is you want to provide a template name here. So the easiest way to do that is just use the change button, or you can go and hit save, or I'm sorry, save as. Since there's no name, you need to do a save as. So we just put a quick, easy button there. So this change button is the same as the save as. Same as the save as. All right. So what I'm going to do is provide today's workshop name, and today is the 30th already. So there we go. Just change the date. And now we can see we have a named template file, and also the button gets renamed as well. So, all right, let me find the conditions here for Adam's system. All right, so the first thing I'm going to be doing is I'm going to be comparing the medium moving average to the slow moving average and checking for that condition first, since that's what he wrote down first. So what we're doing is, let me get back to the chart, right? So we're doing a comparison where part of the condition is to see whether the medium is above or below the slow. So we're just doing a comparison. Add that on there and provide a name here. So the medium slash slow moving average comparison. So let's see, the medium is a 50 period, and it's an SMA. Just using an SMA here. And now we need to plug in the slow moving average. And I decided to use an EMA for this one. It's a 200 period. Now the condition is when the medium is above the slow, that's actually the condition to go short. And you can see BloodHound's giving me a long signal or a long condition. So I need to reverse the output for this solver. So what I can do is right now I have when A is greater than B, give me an output of 1. But what I need to do is I need to reverse it. So when A is less than B. So let me set these to 0. Set this to 0. Plug a 1 in there. And I need to reverse the short output as well. So when A is greater than B, so A, indicator A is the 50 period, which is the medium, the dashed line. So when it's above the slow line, we want a short. So when A, being the 50 period, is greater than indicator B, the slow period, we want a short. So A greater than B, we want a short output there. So I'm going to set the others to 0. Now I'll scroll back. There we go. All right, so we can see when the medium crosses below the slow, now we're getting a long output. So that condition is met. The next one is the crossover. So when the fast, so we're looking for the fast moving average, which is the solid white line. When the fast crosses above the medium, that actually pulls the trigger on the trade. So that's a crossover condition. Throw that on there. We turn the other solver off. So put the description of when the not the slow, the fast over the medium moving average crossover. Okay, so I'm going to put the fast in the indicator A. Put the fast period in there, and we're using 17 period. Indicator B, change that to 50 period. Okay, there's our conditions met. Great, so the fast is crossing down below the medium, or we're getting a short. And then when the fast crosses above the medium, we're getting a long, and so forth. All right, so now the next step. Let's see, the next step, that's essentially it, and then we'll add a MACD histogram filter. All right, so the MACD is the bar type here, the purplish bar type. So let's see. Now what I'm going to do actually is I'm going to build this filter first for the MACD. So the way I like to do, before I start using a logic template, I like to try and create all of my solvers first, because it's just kind of easier just to turn the solvers on and off. So I can go through and set up the solver conditions, correctly, and then it's just easier just to be able to turn them on and off. So as soon as I create a logic template, then I can't turn these solvers on and off. This has no effect anymore. And I'll explain that, the reason why, in just a moment when I start building the logic template. But first, let's build the MACD condition. So I'm going to use a threshold. What Adam is thinking is that you can use the MACD histogram when it's above a certain threshold level, something that's like 0.1, 0.2 or something. And that threshold level, it all depends on the instrument that you're trading as well. Because different instrument prices affect the MACD value. So if this was the ES, the MACD values would be like in the range of 1 and 2. But since we're using oil, and oil's below 100 on its price, whereas the ES is up in the thousands, the MACD for oil, is in the 0.1 and 0.2 range. So just be aware, the MACD is one of those indicators that where its threshold values are dependent on the price of the instrument. So let's add the threshold solver. And we'll change the name here. All right, so the MACD histogram. Get this switched over. And I'm just going to use the default MACD settings here. And NinjaTrader calls the histogram the diff. Technically, mathematically, that's what it is, right? The histogram is the difference between the MACD and the average. You just subtract the two, and that's how you get the diff, or the difference. And it's commonly called the histogram. All right. The next step is to set up our threshold levels. And I'm going to start with like a 0.02 for my threshold. Oops, 0.02. And for E, I'm going to put a negative 0.02. Now this is something critical for the threshold solver, and we're gonna work out a way to warn you about this. But when you put your threshold levels in, you have to put them in a descending order. So the highest threshold value has to go in A, and then you work your way down into descending order. And if you have negative values, then negative values have to be at the bottom. So for example, if I couldn't do like 0.05, if I did something like this where I put a higher number below a lower number, the threshold solver is just not going to work correctly. It's not going to function correctly if I do this. It's partly due because of the output values. If you think about it long enough, it'll make sense to you. But what we're going to try and do is, provide a little warning if you do something like this by accident. So, just trying to think of an example. Like with the MACD, I see a lot of people doing this. So they're looking for, an 80 and a 20. Yes, I'm sorry, stochastic. People are looking for like an 80 and 20 stochastic condition. So I do have the stochastics on here, right? So they're trying to find out when the stochastics is above 80 or below 20 for a certain condition, and a lot of people do this. The problem is that 0 is less than 20, and so it doesn't work when you do this. So you need a value in between 80 and 20 for the threshold solver to work correctly. So what I'd suggest is you can just put 50 in here, and then the solver would work correctly. So let's keep that in mind. You got to keep your threshold values in descending order like this. All right, so let me put these values back. All right, and the next step is to fill in the long output. So I can see here, so when I'm at 0.02 or greater, I want a long output of 1. And then for the shorts, when I'm at negative 0.02 or less, I want a 1. I want a short output of 1. And so there we go. Now if we look at the histogram, we can see the outputs are matching the value of the histogram. All right, so the next step is we'll have to marry all these solvers together on the logic template. So I could actually just, this is a fairly simple system. Now I probably could just use it without a logic template. So if I just turn them all on, I can see that I do have a long signal here, and it looks to be valid to me. So the crossover occurred below the red slow moving average, and our histogram is above 0.02, and there's a valid short condition. Let me stretch these bars out there. So this condition works without a logic template. It's fairly simple, straightforward. But if I wanted to have kind of like a cleaner output, you can see we have kind of an analog output here. If I want to clean that up to have a clean digital looking output, then what we'll do is we'll put this on the logic board here. All right, and I'll just call this my entry. We just drop the solvers on here. I like arranging my logic boards in a certain order, whereas the solvers that kind of give the signal, that kind of trigger the trade, I like to put them on top, and then my filtering conditions I like to put them on the bottom. So this, something to consider. It helps you keep your system. Helps. Let's see, what's the word? It helps clarify your ideas in your head. Let's just say I've seen some really complicated systems, and definitely helps if you kind of organize your solvers into groups so you know what they're doing exactly. Whether it's kind of providing the trigger to take the trade, or whether it's providing a filter or a permissive or like a directional bias. So you could say that these guys are providing a directional bias, right? and then another way to kind of keep your solvers grouped together is I'm going to use 2 AND nodes here. Now really this is a simple system, so only one AND node is needed, but I'm just kind of showing this as an example of kind of how to keep your logic board clean and easily understood if you come back to it a month later. So what I'm going to do is I'm going to rename this, like in this case I guess I would call these a directional bias or a directional filter. So I'll call it a filter. There. So now I know that all the solvers plugged into this AND node are providing, directional filters. And And this guy, anything plugged into this AND node, is providing the signal. So, and then commonly, actually, probably more commonly than the AND node, you might be using the OR node. So you might have two different solvers that both provide valid trait triggers, and you might want one or the other. You don't need both of them at the same time, but you might want one crossover versus another crossover, and they're both valid. So typically you'll use an OR node to pass all the signals through. And so let me just change the name of this, and then to join everything together, we'll just connect both of these logic nodes into the AND node, and it joins them all together. And there is our signal. So you can see we had some crossovers here. We had two crossovers occur right here. Let me circle them. But they were filtered out. The cross down was filtered out because of, I can see, because of the MACD condition. All right, if I wanted to test that, I can take this AND node, plug it into the result node, and I can see the directional bias. There is no directional bias during these two crossovers, and that's why there is no signal here. And I can see here this cross up had a directional bias up, and that's why the signal went through. And let's see. So this signal looks like it should come through. Let's connect this up. Yep, and there's our short signal down. All right, so that's that was that question. And let me, I see some other questions coming through, and I'll get through this, and then we'll move on to the function nodes. All right, so let's see. Let's see, it looks like Gary has a comment maybe. So Gary's making a comment, we seem to cover the same material every week in the workshop. An idea might be to record this and post a link at the beginning of the weekly webinar for new folks. Yeah, Gary, I knew this day is going to be coming where I'm probably going to start doing 2 workshops a week, probably do a weekend one, so that way I can dedicate one of them for new people and one of them for you veteran guys who have more complicated questions. So, but I still want to keep, for now I do want to keep, the workshops open to all questions. Don't want to alienate the new guys. So, all right. So thanks, Gary, for that. And let's see. So Adam, all right. So Adam's in here. So Adam's saying the MACD. This is Adam's question. Adam's saying the MACD settings would be for the MA. The MACD settings would be for the MA. The setting, okay, 17 fast, slow, 50, smooth, don't matter. Sorry, Adam, this is a little too descriptive. I'm not sure exactly what you're saying. So I'm not sure what you're meaning by the MACD setting would be for the MA. MACD setting for the moving average. I'm assuming that when you say MA, you mean moving average. Yeah, so Adam, you said your original idea was to use the MACD histogram, and that's what I've used. Oh, you want to use it as a moving average crossover. Oh, okay. I think I see what you're saying. All right. So instead of using the fast and the medium moving average, instead of looking for a crossover with those, you're thinking about using the MACD histogram as a crossover. So when the histogram crosses some threshold value, I'm assuming that's what you're looking for. So all right, let's build that condition. So I'll leave that gap there. We'll disconnect this. All right, so let's put a new crossover solver on here. So here's a nice new feature of version 1.1. is you can add new solvers directly to the logic board. And all right, just a second, guys. Adam's replying back to me. Yes, and the histogram settings are set for the moving average. So MACD settings would be 1750. Oh, okay, I got you. All right. Well, Adam, I'll just, I mean, you can easily change the period, on your solvers. I'm just going to use the default MACD periods. So, really the concept is what's important here. All right, so we're going to need two crossovers for this because we're crossing over a threshold. So we're going to need since our threshold values are 0.02 and negative 0.02, we're going to need two different crossover solvers, and we'll join them together with an OR node here. So let's set up the first one. So I'm going to plug the MACD into indicator A, and we're using the difference or the histogram. And indicator B is actually an absolute value, which is what a threshold value is, just a fixed value. And we want 0.02. And let's test this out. All right. Here, I'm going to turn the MACD off. All right. And then next, let's put some lines in here so we have a better visual. All right, so there's our two threshold values, and we can see we're getting a signal whenever we're crossing them. You can also see, though, that when we only want a long when we're crossing above the 0.02, right? And so we don't want this short when the histogram crosses below it, 0.02 in the positive. We only want a short when the histogram crosses below the negative. So let's pull up my interface, BloodHound again. And I'm going to provide a name here. And I'm going to copy this solver so I can set up the other signal easier. Copy this. All right. And then rename the copy. There. All right. Switch back over to the logic board. And so we want to eliminate this short when we're crossing below the positive 0.02. So what we're going to do is we can use this evaluate parameter and set it to longs only. So now there's no shorts coming out of this solver. It's only going to evaluate the long side. All right. So let's set up the other crossover solver. This one is going to be used to cross below the negative 0.02. And we need it to evaluate shorts only. And all right, there we go. There's two crosses below that. All right. So if we plug both of these solvers into the OR node, we'll take a look at what's coming out of the OR node. So there's our crossover conditions. And then next, we just need to apply our directional bias. And this MACD, let's see, there we go, it's this one. So this MACD histogram threshold solver is not valid for our directional bias. All right, it's just going to be comparing the slow moving average to the fast. And actually, maybe Adam, this is not a part of your system, but you know, this is just to kind of help you guys understand some concepts. So if we look at the final result, so there's our short. So we have the medium moving average above the slow one, and we have a short there, and we have a couple of longs. Let's take a look. It's kind of interesting. Looks like a neat little maybe scalping system. So those signals aren't too bad. So, all right. I think let's see. Let me just Adam's explained another. There's another comment. Okay. Yes, and the histogram setting are set. Oh no, it's the same we had already. All right. So good, Adam. I think I kind of covered that question, and we'll move on to the function nodes. All right, let's minimize this guy, and I have another chart already set up. Nope, not that one. This one. Okay. So let me explain what I have on the chart. Right, I have two moving averages, and I'm using. I have the crossover solver and the comparison solver using these two moving averages, so that way we get some different outputs. So let's see, you can see here, and I have two instances of BloodHound on the chart. So you can see on the bottom, we're looking at the comparison solver here on the bottom, right? So when the fast white moving average is below the slower one, we're getting a short, and as soon as it crosses above, we're getting a long. So what I did is I just, I built just a couple of standard conditions to help illustrate how these function nodes are working. All right, and then I built this quick little indicator here. I call it a test signal generator, and I will post this up on the website. And also, I'm going to post this template up on there as well. Although I do want to, I want to add some more conditions to it. So the one I post up on the website may not be exactly like this. It actually might have some more solvers, on it, and some other just kind of complete, make a more complete template than what I have today. So just so you guys know. So and I put 2 different instances of BloodHound on here, so that with at least, so we'll have one instance of BloodHound. I'll try and use the bottom one to kind of show the signal that's going into the function node, and then the upper BloodHound will be showing the result of the function node. So let me get both of the interfaces open here. There we go. Yep. So we can see I have a comparison solver. Sorry about that. I'm doing 2 things at once. So I have a comparison solver. As I explained, we're comparing the 2 MAs. That's what we're seeing on the bottom. And here's the upper instance of BloodHound. And I've got the signal blocker in. Okay. So let me just start off by saying, if you haven't updated your BloodHound in a couple of weeks, go through and check to see if there's an update, because we just, Jeremy, about I'm not sure if a week ago or 2 weeks ago, something like that, we just found a little bug in the signal blocker. So so the current release has the fix for that. All right. So to get started, I'm just going to work my way down the function nodes here. So we'll start off with the inverter. Fairly basic one. Alright, so on the bottom, BloodHound on the bottom, you can see that it is, let me shrink these guys up. It is mimicking this test signal generator right here, the longer one. You can see it all lines up there. And we will just invert that signal. Oop. Alright, so BloodHound on the bottom, that's the signal, that's the output going into the inverter. And so there's the result of the inverter. It's pretty straightforward. just reverses, or it doesn't reverse it. It inverts the output. Let's give another example here. So, okay. All right, so once again we can see the signal coming into the inverter. So on this short right here, you can see that there's no short on the inverter's output. And then we have 3 shorts, these blank areas. All right, same with the long. So we have a long signal coming in, inverts it, so there's no signal coming out. And 2 long signals here, with in between the 2 long signals down here. Pretty straightforward. And the inverter has some additional options here. So we can swap the long and short. So now we can see, let me kind of stretch these bars out a little bit. All right. I just refreshed my chart, so let me bring these guys back up here. And okay. So let me kind of start from the beginning here. So what we're looking at is they swap long and short set to true. So we can see this short to this short. Let me draw. There we go. So from there to there, and we can see it's been swapped with the long output here. So now the long output is the inverse of the short signal coming in. And we can see here the long signal coming in. The inverter is swapping that for the short output there. So that one's pretty straightforward, and we turn that off. And so, let's see, for the long side, right, you can turn the long side off, so you're not evaluating the long side at all, right? Now we only have a short coming out. Or we could just turn the inversion off. So now we can see the long signals match each other. Long signal there matches the long signal there, and so forth. But the short, we can see the short side is inverted. Right. So these are pretty straightforward. And you can see we can adjust the signal coming in. You can see that the slider is having an effect on the actual bar. So the signal coming in, we can see the signal coming in, that as I adjust the slider, the bar that's getting inverted is shifting in value. So if we set the slider to 100%, right, then it inverts to 0. So let me kind of get a better marker on here. Let's see. I'll use the arrow. So let's take a look at the bar that has the arrow on it. And so we can actually adjust the value of that bar there. So essentially what I'm doing is if I lower the signal coming in down to 0.22, then the inversion changes. So the inversion of 0.2 would be 0.8. So we see this bar now is at 0.8. Essentially the inversion of 0.2. So that's what our slider is doing. Although most people don't use the sliders, and that's when you really start getting into using some fuzzy logic and stuff. Alright, let's jump down to the long and short modifier. Just give me a moment to get the logic board set up here. And actually, let me go back to yeah, let me go back to this solver. This one was a better demonstration. So this solver here, this one that we're using, is the slope, the change in direction, the slope change in direction. So let me just show you here. The solver node is the change in slope solver. And that's what this guy is. And the reason why I'm using it is right, because it has a stepping type of an output. So let me show you the output here. So we're using the SMA 14, right, which is the white moving average on here. And as the slope changes, right, we're varying the output. So we can see this solver has, you know, a stepping type of an output. So when we're strong in direction, we're getting a 1. So if we look, let's see here. Look at the solver here. So we have these two outputs here and these two bars. are meeting our signal, and we can see that the slope condition on the moving average is pretty strong. And it's kind of hard to see, but I can tell that the slope is starting to drop off on the next two bars. And you can see that the value, the solver's output, steps down as that occurs. Let's see if I can exaggerate this. Sometimes you can see it if I exaggerate it. Doesn't seem to be helping on this, but let's take a look at these two bars here. So we can see the slope of the moving average really is beginning to steepen. And so we're getting a painted background, right? So our output for that solver is at 1 and 1. And then we can see that the steepness of the angle is, it's lessening, right? And so then the value, the output value, steps down as the slope decreases. So that's how that's what this solver is doing. We got the output on the bottom, and then we're taking that same solver and feeding it through the long and short modifier, so we can take a look at all the different modes that it has. So the addition, so right now, let's see, are we starting at the top? Let's start from the top. So I'm going to put it on swap. So swap, pretty simple. But you can see that when there's a short, it swaps it for the long side. And so when we have a long signal going into that function node, it swaps it for the short side. So another way you could say that is that it's in swap mode, it's kind of reversing the longs into shorts, and the shorts into longs and the longs into shorts. So swap is pretty straightforward. Now we can mirror the long side. So we can see here when there's no long output, there's no output from that function node. So you'll see that both the long and the short are mirrored from the long. So the function node is only evaluating the long signal coming into it, and it's going to mirror it for the long and the short. So you can see the long and the short coming out are both exactly the same value, and they match the long coming into it, the long value coming into it. So as the long value steps down, right, we can see the output steps down for both the long and short. And let's see, here's a good example. So this bar here, we can see the short has a, in a sense, it has a greater value than the long. But in this mode, it's just being ignored, and the output for this function node is just mirroring the long, which is shorter than the short. Boy, this is quite some tongue twisters here. So now if we move on to this mirror short, then that's going to be pretty straightforward. It's just going to be evaluating the short side only and mirroring it. All right, so we can see as there's a long only coming into the function node, there's no output. right? And so now the short side is what's being mirrored on the output of that function node. So now you can see with all these capabilities, that's why I'm going to post this chart template and this indicator up there, so that way you guys can go through it at your own pace and experiment and test away. All right, let's take a look at the average. And let's see. All right. So the average is taking the all right. Now let me take a quick look at this so I can get these all straight in my head. Yeah, that's why it's a little trickier. All right, so let me just check something here. So we're valuing the long and the short, and hey, Jeremy, are you there? Can you pipe in for a moment? Well, I guess Jeremy's off working on some other stuff. What it's supposed to be doing is, unless I'm understanding this wrong, it should be averaging your inputs. It should be averaging your inputs, and essentially it looks like it's doing. So if you look at the shorts, right, you can see we have three short signals here, and then as it steps down, it's averaging them. Initially, I thought it was averaging the long and the short. It was taking the average of the long and the short, and that was your output. It's kind of looking. I'm going to have to pass this one on, come back to this one later, and have Jeremy pipe in here and explain exactly what it's averaging. Because I thought it was averaging, the shorts together, and then we give you an average of the shorts out, and then taking the longs, and averaging them. But it's clearly not doing that. Yeah, there you go. Thanks, Jeremy.
The long and short modifier is supposed to average the long and short confidence values.
So it's averaging what, the long and short of the same bar together?
That's correct, yes.
Okay. All right. Because you can see that there's no long output and there's only a short output, and so maybe we just caught a bug on air. So it looks like the average should be 0.5 instead of 1. Right. Essentially, it's taken the long.
Coming in, the one and the values coming in is 1.
On the short side, the value coming in is 1. On the long side, it's 0. So essentially, I think so it's adding the long and the short together of the same bar and then divided by 2.
Exactly. Yeah.
Okay.
Well, maybe
Yeah.
meanwhile I'll just quickly check that up and I'll get back to you guys. All right?
Yeah. So yeah, there's just a little simple mathematical bug in that. It's interesting how you can just one little simple mathematical leaving out a negative or leaving something out when you're coding and give you some oddball results. So I think we just caught a bug on there. So we'll kind of we'll get that one fixed and released out. Now, so the way it should be working is when there's no long out input, but there's a long output of 1. I'm sorry. Let me start over. Tongue twisters here. The long output equals 0. Let me kind of mark the bar that I'm working with here. So I'm not sure how well you guys can see my crosshair. So let's just mark this bar. This is the one we're working with. So we can see the long side is 0. The short side is 1. So if you average them out, you should get 0.5. But it looks like we're taking a maximum value here, in a sense. But I can see that's not the case with these other bars. So it's just we got a division bug in this guy. So that's what should be happening. So if let me scroll over here. There. So to reiterate, the 0 value is for the long side, and the -1 is for the short side, and the average of those two is 0.5. And so we do have 0.5. Oh, good. So what I need to do, that's right. I forgot. NinjaTrader is self-adjusting, right? The scale is self-adjusting to the greatest value. So let me shrink the scale down. There. Now it's making sense. So everything does appear to be correct. You just got to be aware of the NinjaTrader's auto scaling within the subpanel. Yeah. So we can see our output from the function node is 5 and -0.5, so it's averaging 0 plus 1 divided by 2 is 0.5. So let me step forward 1 bar. Oh, a couple bars. All right. So now, if we evaluate this bar here, so we have 1/4 plus 1/2, right, for 3/4 divided by 2, and you get 3/8. So there's our output. So that's what averaging is doing. Taking the long plus the short and averaging them out. So, all right, everything's working good. I just wasn't paying attention to the scaling factor. All right. Good, good. Let's step through the next one. All right, maximum. Pretty simple. Just take the maximum of the long and short. So on this same bar here, let me delete this. So the short side has the maximum value of 0.5. So the maximum is applied to the long side here of 0.5. So you can see the long side, the input is 1/4, but on the output it's 0.5, set to the maximum. Pretty straightforward there, and let me kind of step backwards, and so we can see the input down here is 0.5 and 1/4, so the maximum is 0.5, and so that 0.5 is also applied to the short side. So now we have an output of -0.5 instead of 1/4. And minimum. Minimum ought to be pretty straightforward. So now the minimum input is a quarter. You can see the input on the long side was a half, and now both on the output, the long and the short side are a quarter. And so we can, oops. So let me scroll back one bar. So we can see there is no short input. So the short side is set to 0, and therefore there's no output set to 0. So the minimum is 0, and so the output is 0. So it's almost 12 o'clock, so I'm going to try and get through the rest of these, and we'll wrap it up there for today. So product is the mathematical term for multiplication. So if you have 0, you can see our input here is 0 and 1, right? So 0 times anything is 0, so there's no output. Let's step back. So we have a quarter times a quarter, and so that gives us a fourth of a fourth, which is 1/16. Right, so you can see our output here is I believe that's 1/16, right? 0.0625. Let's see if don't really seem to have any good examples from this solver, the input of this solver. Yeah, I kind of already showed you this. We have a quarter times a half, right? A quarter times a half gives us what, 3? No, an eighth. Yeah. So a quarter times a half is an eighth, or a half times a quarter is an eighth. So, right. So there's your product mode or multiplication, and then addition. Straightforward. Just add the two together, right? So we have a half plus a quarter is 3/4. So we can see our output here for both the long and the short is 3/4. So we have next bar. So we have a quarter and a quarter. Add them together, we have a half on both the long and the short. So addition is pretty straightforward. And difference. So difference or subtraction, right? So a quarter minus a quarter is 0. So here we have a half minus a quarter. So you probably kind of caught on that all these mathematical functions are taking the absolute value of the short side, right? So just to kind of kind of give some background. So the way BloodHound evaluates the short side, internally it's actually evaluating it as a positive number, but to represent it in an understandable way on the chart, we have to invert the short side to a negative, right? So internally, BloodHound is evaluating the short side as a positive number from 0 to 1. But just before it puts it on the chart, it inverts it, so that way you don't have the short side and the long side, stomping on top of each other if they were both positive. So internally, BloodHound is taking 0.5, right? Not negative 0.5, but 0.5, right? And subtracting a quarter out of it, and that's how you get a quarter. So when you're looking on the chart, it looks like we're taking the absolute value of the short side when we're doing these mathematical functions. So, but you know, I guess either way, you know, you can realize that internally, BloodHound's just taking the short side is a positive value, or you know, you could just look at it as taking the absolute value of the short side. Either way, both works out the same. So if I step back one bar, right, so we have 1 minus 0 is still 1, and therefore both the long and the short is 1. Step back one more bar. So yeah, so we have a half minus a quarter again, so we already did that one. Alright, so let's go forward. Let's check out the next mode. Divide. Yeah, so division. So here, a half divided by a quarter is should be 2, I believe, not a half. I'll have to check on that one. Yeah, and so there, maybe there is a division, you know, doing division in computer, you know, there's all kinds of things you got to watch out for. You know, one of the things is like if you have 1 divided by 0, you know, in computer language you get a divide by 0 error, it crashes your program. You know, so you always have to write these special little subroutines to catch zeros and things like that. So we can see 1 divided by 0 is 0, so we're getting the correct output there. And when we get to 0.5, well, I guess it depends on how you're dividing it. So I think what Jeremy's doing is what we're doing here is we're taking the smaller value and dividing it by the greater value. That way we don't go over 1. That way our output's not greater than 1, right? So if we take a quarter divided by a half, that does actually equal a half. So once again, when you're programming division like this, right, Jeremy's had to write a special routine to find out which value was greater to make sure that you divide the greater one into the smaller one. And let's step back here. All right, so we have a quarter and a quarter.
Yeah,
right? So
if I may just, there's actually, if you go back to the divide, go back to the long-short node again.
On the chart or on the template?
On the function, yeah. So there's actually 2 modes there. There's divide long over short and short over long. And basically, if the divisor is sorry, the denominator is 0, it just returns a 1. But otherwise, it will divide. It'll give you a ratio that looks just like that. So short divided by long, or long divided by short.
Yeah. Sorry, I didn't notice this mode, divide mode. Yeah, so when I changed the divide mode, so now you can see that we have a quarter. I'm sorry, now it's short divided by long. Yeah, so we have a half divided by a quarter, which is 2, but we cap it at 1. So there's the output of 1. And if I put the divide mode back to where I had it, Now we have a quarter divided by a half, which is a half. All right, and so if I step forward, not stepping forward. Okay, so in this mode we have 1 divided by 0, which is 0. And if I flip those, I'm sorry, let me restate that. We got the long divided by short. So 0 divided by 1 is 0. And if I flip these, so essentially when I flip them, you can see that we're not actually, we have the 1 divided by 0, and we still have a 1, so you can see that we're not really doing a division by 0 in this way. And just trying to think of a clear way to state this so I don't make it overcomplicated. Right, so when we're taking 0 and dividing it by anything, we're going to get 0. But in the opposite terms, if you're taking a value and dividing it by 0, you can't do that with the computer. Right? You get to divide by 0. You know, mathematically, you can't divide anything by 0. So we're just not performing.
Zach, just to clarify that, if you divide by 0, you get a number that approaches infinity. And so what I've done is just that if your denominator is 0, you get a 1, which just represents that the ratio of your top value over your bottom value is much greater.
Right. Yeah. As you approach 0. Yeah. Yeah. So you actually can't divide by 0. So we have to make some kind of a judgment call, and so essentially you just so you're just not performing any kind of function there, I believe. All right. Let me change. I can change the solver's output, and we can test this. Let me find a bar here. Okay, so this guy. So I'm going to take these 2 bars here, and I'm going to play with the output of this solver to give you an example. So let's see. Yeah, so I'll set this to 0, set that to 0, set that to 0. And I need to change this one as well. And so right now the mode we're in short divided by long, so the short is 0, so our output's going to be 0. And if we take the long, which is 0.5 divided by 0, is, okay, so essentially anything divided by 0 is going to be 1. Since, like what Jeremy said, it approaches infinity, and we can't display infinity, so we cap the output value at 1. Right, so anything divided by 0, you know, we're capping it at 1, because we can't really display infinity. So there's the divide mode, and essentially none. So let me put this solver back to the way I had it. So as you can see, none essentially just kind of this function node just becomes a pass-through. So, right, no mode, no evaluations taking place. Right? So, and then simply enough, you can just turn the long side or short side off. If you know if you have a system where you have a whole bunch of rules for the short side only and the long side only, that way you can turn the long sides off or short sides off. All right, so I'm going to kind of leave it there for today, and we'll pick up from that point next week. So let me kind of go through. Looks like there's some comments or questions here. So Daryl's asking, Jeremy, would you be able to demonstrate a more winning strategy? So, Daryl, I'm not sure exactly what you mean by that, but just to let you guys know, we're not coaches. We're not selling you, pre-baked systems to run. We're giving you the tools so that you can take what you've learned and get a nice clean indicator or a nice clean signal out, so that way you're not evaluating, a whole bunch of different indicators before you can take the trade. So what BloodHound is doing is it's doing all the indicator evaluations for you, saving you time so you can hit the entry trigger sooner, or if you like, you can take the BloodHound signal and put it into Raven and have Raven execute the trade and put you in the market. And then you can manage it afterwards if you want to be discretionarily manage your stops. So we're not in the business of selling pre-baked systems. We're primarily in the business of providing the tool, to get you to become a better trader, get you in the market faster, help you evaluate all your indicators and your system rules faster. So, but I would like to follow up that we do have a coach. He's a licensed securities broker who will be doing some training, and he's going to be a new NinjaTrader partner here in the next week or two. He'll do his first webinar with NinjaTrader and launching his business, and he is using BloodHound, and he does have some systems that come with his that come with his mentorship, his training, and we've had several other people approach us to find out, if there was a way to obfuscate or essentially hide the code, because we have some people interested in marketing their system, but first we need to come up with a way to hide that so that we're not giving away someone's system. And so once we get through the divergence and the Fibonacci indicators for BloodHound, we should be approaching that fairly soon, so that way we can get these people to give them a way to market their system with BloodHound. And so we'll kind of have like an app store for systems that other people have designed, and they can lease their system, or however they want to market it. They can market their system on our site for BloodHound or on their own site. So that'll be coming, Daryl. So let's see. All right. Yeah, let's see. Gary, so could we use the long-short modifier average to get a better fill on an order? I'm not sure, Gary, how you would do that. I'm not sure what you're thinking is. Let me read your next statement. So instead of an order getting a fill at the top of the trigger bar, we could average and get a better possible fill. You know, Gary, it depends on how you're running BloodHound. If you're running BloodHound with calculated on bar, typically BloodHound is run with, let's see, where is it? Calculate on bar. There we go. Calculate on bar is set. Calculate on bar close typically is set to true. So what that means is that the bar has to, you know, a new bar has to start before your indicator gives you an output. So if you're running BloodHound with this set to false, right, then BloodHound is evaluating, you know, is evaluating the current bar that's being built in real time. So let me cancel this, and I believe I have some data coming in. And let's see. Yeah, so maybe this solver will give us some output. So let me change this instance of BloodHound. I'm going to set calculate on bar. Let's see, calculate on bar true. Let's see. Oh, it was set to false. Okay. Yeah, this one is set to false, and this solver is evaluating the SMA 14. So let me set this indicator to false here. Calculate on bar close to false as well. Oops. There. Well, it doesn't. I wonder if. Oh, I think the oil market is not closed, but I think the pit is closed. So, yeah, therefore it doesn't look like there's a lot of action going on. Let's see if there's some action going on in the 6E. Yeah, just doesn't seem to be a lot of action going on. But Gary, you know, I'm not really kind of seeing the same thing that you're thinking you can do with the long-short modifier for getting a better entry. But I guess it's possible. And if you did, I think you would have to be running BloodHound, you know, with calculate on bar close set to false as well, to possibly obtain a better fill. So I guess, Gary, I kind of need a little more explanation from you on what you're thinking there. So sorry, I couldn't really give you, I couldn't understand your thought there. So let's see, Randy. Oh, Randy's just going to help me out with my math there. Thanks, Randy. All right. So, you know, Gary, you know, just a reminder, guys. You know, if you need some help with something, you know, you can book a one-on-one appointment with me. So I'm here to help you guys out with BloodHound. And so when you have, you know, some good complicated situations, that's what I'm here for, and I'll help brainstorm with you guys. So, all right. Well, with that, I'll wrap it up for today. And Jeremy, any other last words? Well, Jeremy might have had to step out. So, all right, guys, we'll leave it at that, and we'll pick up next week where we left off here. So, thanks, and have a good week. Bye-bye.